Alrighty, I think we're good. Should probably get rid of some of these extra GLTF files. Now that I have a bunch of stuff working. Power level. Okay, let's get rid of all of these. I think. Yeah, get rid of these. Get rid of these. I think debug and event ordering are relevant. Did I... No, this doesn't use the GLTF file. So we're good there. This is stuff from the airport. Okay. I think that's all good. And then I think the extension is installed. But I guess let's kick it from the beginning. So Blender, add-on already installed on the right-hand side here. Go for, oh, it's probably blocking. I'm probably blocking that with my face. Hang on. That's like the most important side of the stream for the moment. Transform, flip horizontal. Perfect. Okay, so we've got nothing found because I haven't done the fetch yet. So we've opened Blender from scratch. The add-on is already installed. We open up the command palette, fetch Bevy type registry, and then I get the idea that the current application isn't running. So we should probably make that request have a different error. This app doesn't do anything. It just sets up component information. So this is now a running Bevy app that serves up BRP endpoints. Let's move that desktop like over there. This one over here. Cool. So now I should go into here, be able to fetch this registry. There's a bunch of logs because I haven't gotten rid of any of my logs yet. And then over here in the bottom right, which I can make bigger. Yeah, 1.42. There we go. So over here in the bottom right, I think we can do player. I think that's one of the ones that currently works. We'll insert this component. We get a form now to fill out some data on this component. So I'll do like my name maybe, and like drag this, and you can see how the value is kind of like getting updated on the left-hand side here. There's a bunch of logs that are kind of like pretty noisy, but it works when you tab from thing to thing, and then so you get like the serialized data out at some point. So when these forms change, I have like an update handler that goes through everything, grabs all the data, serializes it to JSON. So it should be like on this object now. So if we export, let's disable this for a second and enable custom properties. We'll go to GitHub. We'll go to the repo, assets. Okay, so this is custom props. We're going to do this as GLTF separate, export, and we should be able to go look at the GLTF file, and we get, first of all, this extension, which we haven't talked about yet. That's the box I just clicked. And then this data. So all of the form data, all of the component data, adding it to objects and stuff, that all works. The format of this data is not quite what I want it to be, but you'll see if this is the key and this is the value, then we have everything we need. So we really just need to get rid of like this stuff, the active component index here, and just leave that in the array. And then that'll all come into Bevy, and that will all just work. There's a bug fix that I need to do in the Rust code because I'm effectively changing from an object to an array here, but haven't made that change yet. So all of the Blender UI code works in that sense. The Python for this project is currently at almost 800 lines of Python, which is a lot. The Rust is like 400, and most of this file is tests. So yeah, tests start here. So now we're at 200. And then if you look at the actual code up here, a lot of this code is like just being very explicit about error handling, because people who use this in their games or whatnot will have no insight into what's going on at all. So making sure that those error cases are properly reported is very important. Whereas normally I might just do like a question mark or something. Currently, we only support GLTF extras, but the code is written in such a way that it supports material mesh and scene extras in the Rust side. Maybe we split that up at some point, but for now, this is working. And then the last bit is the piece that I was working on my flight yesterday, and that's this GLTF export extension. So the export extension, if we go into export here, we do GLTF export. We do like extension here. And I put this in a place where it can actually be seen by anybody. Can I not scroll over here? There we go. So we've got this little checkbox here. There's no other options currently. So it is what it is. So if I check this and I hit export, obviously the panel re-renders and those logs are very noisy, so that happens. If I find the right place, we should see additional logs. This should have been the export. Maybe I got rid of the logs. That's possible. I don't remember what I did yesterday. But basically, when this exports, it should now run our code, at which point we can transform the data from what's in the custom properties to the format that Bevy already wants. So rather than like doing some transformations in the Rust code and like having some junk data in the GLTF export, we can clean it all up in the GLTF export without needing to do that in different places. So I think I'm going to get rid of a bunch of these logs as the first thing, because doing this export is kind of noisy. And like working with the export extension is kind of annoying because you actually have to install it. You can't really get around that. And that's because the export extension code for Kronos's GLTF2 exporter requires this class name to be in this module, and it can't find this module if you just run it as a script inside of Blender. So it has to actually be the installed add-on, because that's where it looks for this file, effectively. Hello, what you're doing looks really cool. Great, cool. Glad you find it interesting. I think we're reaching the end of the like project in terms of like having the full loop working. So I'm hoping to finish that up on stream today. And then from there on out, it should just be making sure that we set up the forms correctly for all of the different kinds of types that can come from Bevy. So right now I have, I think, 2 of them working properly. So I've got this like test file here. This is all the reflection data coming from Bevy. This is the registry type data, effectively. So one thing we're not doing currently that I would like to add as a feature in the future is a lot of these types reflect default on these components. And when they do that, it would be nice to have like a little checkbox in the UI to be like, hey, use the defaults. Or I don't know how we would discover the default values. I think we would have to like actually instantiate one to find the default values, which I don't think we can do reasonably. But maybe that would be a possible thing in the future. But those are all the base types. So this is like string and F32 and whatnot. We've got marker components. Marker components don't have any data, so they're not super interesting. This is the one that we were just working with. So player. Player is a struct with a 3 fields, so name, power, test. That's string F32, I32. It's a component. I don't know exactly what to do with the required fields here yet. I don't know how to best use that information because I feel like in Blender you kind of have to set everything anyway. So TBD about whether we do anything with that. And then this is one of the types that we're not handling currently. This will probably be one of the later types to work with because an enum can basically be one of anything else. And then we're using task priority. Task priority works currently. Task priority is one of a set of strings. So it's like a regular enum. And this one works in the UI. This is just a combo box. So, yeah. Yeah, nice. One of the use cases you've seen in other game engines is having an entire Blender scene be exported and able to be consumed directly. Is that the next stretch goal after this is done? What do you mean by consumed directly? And the reason I ask that is because Bevy already supports like using GLTF files. And not just single scenes, but like a GLTF file with like 5 scenes in it, 100 scenes in it, whatever. You could put your entire game in one GLTF file. So like scenes, animations, all that kind of stuff already works. The materials and stuff all work. This is specifically the only piece that's lacking in terms of what you can do in Blender to define data that's used in Bevy is the component data in Bevy doesn't exist in Blender. So this puts that component data in Blender. Like from what you understand, this exporter is to clean up the GLTF file so that the exported GLTF file has some attributes to it, correct? Yeah, so the GLTF extras, I think I can just show that. This is one of the older GLTF extras or GLTF exports. This one happens to be kind of semi-handwritten, but so in the GLTF file, there's scenes. So this scene happens to have a node. It uses node 0. This is nodes. This is node 0. Node 0 is just an empty. It doesn't have anything on it. That's just for development purposes. It doesn't matter that this is an empty or not. And then GLTF extras is where that extra data comes in. And this is the set of components. So in this case, it's a character with a name component. And this is the only piece that needs to work, right? Everything else, like your regular GLTF usage, scenes, geometry, textures, all that kind of stuff already works. So you were thinking that you would composite a scene in Blender and the custom exporter would export the individual attributes correctly to each model. Yeah, so have you worked with Bevy before? I was just kind of assuming yes, but is probably relevant. Okay, so that's relevant to talk about then. So in Bevy, this is a Bevy app. TLDR, app new, we register a component type here, character, add some plugins. This is our plugin. These are the default plugins. We add some systems, just logic for startup, logic for like running in the update loop and stuff like that. This happens to be an observer that we add. And then that character component is defined as a struct that has some data on it. So in this case, it's just got a name field that's a string. We derive some stuff up here, but it's not super important. The only really important part is that we're deriving component, which writes some code for us. So when we spawn stuff in like this, and these are components. So in this case, we have a camera, transform. In this case, we're spawning directional light, and these are components. These aren't like commands.spawn creates an entity and then inserts these components onto that entity. And that's what drives behavior in Bevy. So what makes this entity a directional light is that it has the directional light component on it, right? So when you do GLTF stuff, you spawn it like this, right? So commands.spawn creates the entity. We create a root scene entity, and then the asset server loads from the GLTF file, scene 0 in this case, from this GLTF file specifically. So that spawns a whole hierarchy of stuff, right? And if you want components on anything inside of this hierarchy, it's kind of annoying to reach into that after you spawn and try to like place colliders or place any other components that you would want on those entities. So the Blender add-on allows you to define that component data. So in this case, it's player with like a name, power, and test. And that is currently on this cube, which is part of the scene. So currently, this data comes out in GLTF extras, like we can see here. So you have your nodes. This is the hierarchy into the scene. It's got some GLTF extras. This GLTF extras like data gets processed by our Bevy plugin using Bevy's reflection support, right? Also, hello, Andrew from Bangkok. So we're using Bevy's internal reflection for this component data, which already exists. And we can basically take this data and use it as the value of the key, or value of the object, and use it as the key of the object, and this will reflect into an actual component for this node when you spawn that scene. And turning this data into actual components is the part that doesn't exist in Bevy. Yeah, cool. You didn't know it was already handled with the whole hierarchy. That's really cool. Yeah. Yeah, I mean, like, if I explain it to you, then I explain it to everybody who ever watches the stream, right? So it's always useful to answer questions and stuff. So the place the project is at now is that this data structure is kind of like what we need inside of Blender to make it look nice to display. This object needs to have a name because we need to display it in this list specifically. And to display in this list, you have to have a name. Or you have to have some value there, but by default is a name. If we wanted to do it, we could do a custom UI list implementation, etc. And then we have the type path, which Blender doesn't really use except for exporting the data and the value. And then here's something I was testing. And then the other thing that's an issue is like we just have some junk data in here, or what would be junk data for people consuming this inside of Bevy, right? Like you're never going to need to know which component in the UI you had selected. But the way Blender works is you can only attach attributes to, well, you can attach them to basically anything that has an ID or that is an ID object in Blender, but that means like objects, scenes, the window manager, things like that. So for the most part, it has to be like this field has to be on something, and that something is very likely going to export with everything else. So this is junk data for people who are using this GLTF, but it's not junk data when we think about how we want to render the UI and whatnot. So let's get rid of some of these logs to start with. And then we'll go through the process of packaging this up and actually installing it. Let's go for init.py. Find these logs. And this is class. These things can go. I think anything in draw can get commented out for the moment. So this is our panel. Our panel sits in a specific place in the UI. It renders specific things, et cetera, et cetera. So the way you do UI is kind of like you have this layout object, which is self.layout in this draw function inside of the panel class. And you just do like .row, .column, .whatever. We can create buttons with .operator. We can render lists with template list like this. The only downside is that all of these things need to be Blender properties, which is really annoying. They can't be like regular Python lists and dicts and stuff. So are you making another Blenvy? I'm not making another Blenvy in the sense that like Blenvy does a lot more stuff than this does. This is literally take registry data, put it in Blender as UI, export to GLTF, instantiate in Bevy. Blenvy does a whole bunch of other stuff, like it has support for blueprints, it does its own GLTF loading. Like Blenvy is a bigger project than this is. So I did this partially because I'm doing a game on Saturdays where it's starting to get kind of painful to not have this kind of tool. Blenvy is in kind of like hiatus for the moment while the maintainer is doing some life stuff. So I figured now is a good time to dig in and get a better understanding of like both the registry data in Bevy and also how this gets built inside of Blender, so that when Blenvy comes back to life in the future, I have a better idea of like how it works and how like easier to make PRs, easier to understand, easier to explain it to other people, all that kind of thing. So it's like a cut down, very, very cut down version of Blenvy. Yeah. Okay, so the export stuff happens here. This is our UI for drawing like options for the exporter. I don't think we have many options. It's either on or it's off, and if it's on, it's going to reformat the data, and if it's off, it's not. A bunch of these logs should be happening. So maybe I bring these back. I thought it was doing the one inside the class. Yeah, basically, the Python code for this project has been the biggest time sink. So for this, we can... Oh, and I'm like making sure that it's super maintainable for me personally. So I have like a bunch of tests and stuff. I have PyTest set up for how the forms and stuff get constructed. Right now I have it intentionally failing, but Anyway, let's go into here. I basically have a bunch of just files. So if I do just build, and maybe, I forget how to list like the actual commands. Can I list the... Anyway, so to actually build this, we have to run the Blender CLI with the command extension. We build using a source directory. So this whole project is set up in that way, where it's this extensions directory. And then we've got our init.py and whatever in here. So this calls out to Blender on the CLI and creates this zip file. The zip file then, I need to pull it into Blender. So let's pull this over here. That's not what I wanted to do. How do I get rid of the sidebar? That I can never remember. Oh well. Okay, so we've got this zip file now. And we need to go into preferences, add-ons. We've got this Bevy scheme now. And I think we should be able to do this. And I think it should replace it. I'm not entirely sure. Oh yeah, it definitely did. So right now I have this thing where you have to have already run the like Bevy reflection or Bevy type information stuff. If you don't run the type information stuff in development, then you don't get the form to show up and whatnot. So we're good here. We're getting this data. So if we export GLTF, why is this not showing any of the other GLTF files? Assets, GLTF. I feel like I'm in the wrong directory, but I'm not. Okay, something went wrong. In execute, oh, we see it in our terminal. Perfect. I don't need to look at it in Blender. Okay, so this is the part that becomes a little hard to debug because this goes into the GLTF add-on and bounces through into another GLTF add-on file and then calls your stuff. And it calls your stuff by like manually going and getting your add-ons module and looking for a specific class inside of it. So the debugging path is kind of like really awkward in terms of where does the data for this error come from. That's very nice. You're currently running into some issues with Bevy in its current weird state. So if this will help you help Kaosat, that's amazing. Yeah. Yeah, I don't know what they want to do when they come back. I'm kind of just doing this for myself at the moment. When it works, I'll tell people about it. It's built on 0.16 stuff. So it's not particularly, like, it's not that it can't be made to work with 0.15, but I haven't tried to make it work with 0.15 yet. So I'm basically going to finish it in 0.16 and then I'll backport it. My other game is in 0.15, so it's actually kind of important for me to do that, but... okay, GLTF2 pre-export callback takes 0 positional arguments, but 1 was given. So we're looking for this function. And that looks like one of these two. It's got to be this one. So unfortunately... we have basically 2 options. Like I can keep zipping this up or I can write a new just command. And I think I want to write a new just command. So this other terminal has, oh, that's still a symlink. That's not good. I don't think that's good anyway. Let me make sure that we have everything committed here before I start messing with a thing that can point to all the data. Push that up. Let's unlink this. Okay. Well, I've messed that up. So I tried to symlink it. The symlink didn't work, and then I reinstalled the add-on, and I think it threw the add-on into the symlink. So I'm doing great. I'm working with symlinks very well at the moment. Apparently, Blender can't work with symlinks or something, so I don't know. It didn't really work. That's my PyEnv stuff. Nothing seems to have gotten overwritten, so I think we're still good. Maybe I just messed up because I'm in new shell and I don't know how new shell works with symlinks. Maybe that's it. Why would it work that differently? Do disk size. Yeah, that's what I expected that to be. Symlink. Link. Unlink. I really, I don't like the dereference symlinks to their targets for size. I do feel like anytime I see like Algolia search or something, it's always like a really low effort semantic kind of search, and it is never what I want for tech stuff. Okay, there we go. I think I just did it. So if I make this directory and I grab this directory and I put this directory into the just file and I say a new task called like copy for dev, and I'm just going to hard code my path in here. At the moment, if anybody else ever wants to work on this, we can definitely throw, I need to backslash this, don't I? We can definitely throw like the Blender paths in here or whatever. But for now, I'm just going to make sure that this works at all. Because going through the whole install process is kind of annoying. So I would like to automate that. So let's try to see if it works. Just copy for dev. And then I guess we need to change something to make sure that it actually worked. What problems are you running into with Blenvy, by the way? I didn't ask, but I was curious. Which of these hooks was having the error? This was the pre-export callback. Okay, pre-export callback 2 and 2, just to have that be a change. Copy that in. And then I don't know if that will actually run it or not. This is now failing on pre-export callback again. So maybe that didn't work. Maybe that isn't the right location. Takes 0, but 1 was given. So is it actually that it does take an argument? I feel like it's hard to figure out which direction that error is in. Because, like, the GLTF exporter is using our module to call a function. So we would have to go into, like, the source code there to really figure out what is actually happening here. Like GLTF Blender export save context export settings. And the pre-export callback takes 0, but 1 was given. Why does it take 0? I do think our copy in here is not working. This little development thing. Watching my channel gives me inspiration to get back into coding. Nice. That's awesome. I love that. What kind of coding do you do? So I don't want to have to like restart Blender every time. I guess we'll just keep installing this then. Export GLTF, export. Okay, cool. So I do think there's a problem in that if we keep installing this add-on, it keeps installing the add-on over and over. And thus, now that we've installed the add-on 4 times, we're running the export 4 times. So that's sick. Gotta fix that. I only see one of them. That doesn't feel great. Right now, just jumping into Bevy, nothing concrete yet. Nice. Bevy's great. This is the part of extension building that is like, could be better, is kind of the way that I'll phrase it. Okay, type registry. Let's do what is it? Task priority. Task priority will give us something that's a little bit easier to deal with. And then I've got to go all the way back in. Does this let me rename it in Blender, or do I have to rename it on disk? I can't rename it on disk. Oh well. I don't know. We'll go with untitled for now. I don't need to keep... oh, I did the wrong export. Export GLTF. That. And then let's get a couple of spaces in here before we hit it. And then we're hitting our gather node hook. But we aren't hitting the pre-export callback? Is that true? Maybe that fires before it can log? I don't know. The only thing that I see running here is gather node hook. Oh, there's I don't know too. There we go. So this one is the one that's running. So these are not class functions. But gather node hook is? Oh, that is really confusing. Let's go to check the Chronos repo. The documentation on this repo is not great either. So you have to have a class named this. You have to have this code here to instantiate an extension so that you wait a little bit. You have to install it because it goes to grab it. And then they just say define functions that contain the data, yada, yada. There's a bunch of these that are implemented. I think gather node hook is here. And pre-export hook is here. So for me, the question is, this is what we had before. It ran this GLTF2 pre-export callback. So is this in here? No, that's not even documented. Sick. I don't know where I got that. Undocumented function is running. Gather node hook is running. Pre-export hook did not run inside or outside. Gather node hook did run. So is pre-export hook in here? Pre-export hook is in here. It's supposed to work. But I didn't see it run in either test. Right? Pre-export hook in class, pre-export hook. Both of those should have printed. Neither of them printed, unless this is stomping the output. That's another possibility. GLTF2 export, cube, hook. So the question really is, let's just do print GLTF2 object. And I think we've got to do the whole dance again. So that's a node object. Sweet. That means a lot. What is a node object? I'm assuming it's this. Get a little bit more space here. Node in the node hierarchy. When the node contains skin, mesh primitives must contain joints and weights. There can be a matrix or any combination of transform, rotation, scale. converted to matrices and post multiplied to compose the matrix. Don't care about the TRS stuff. Init. So we get camera, children, extensions, extras. So we have a node. That is what we need. I think extras is what we need to work with. So if we do object.extras, then we should see our data pop up. I do wish there was a better development flow. So I'm definitely going to try to figure that out at some point. None. So is that none because we've rebooted? Yeah, maybe because I've reinstalled. Let's set that to low and export. None. Let's get the other player in here. Oh, you know what? It might only be in extras if you check the extras export option. So that's really important to know, I think. So I wonder if there's a way we can set that for people so that they don't have to set it themselves all the time. Because if I do export here and I click custom properties and I export, yeah, okay. So we can only access the extras that are supposed to be there if the user has selected to export the custom properties. That's kind of unfortunate. Do we have any other data on this node? Like, can we get that data regardless? I'm kind of like 50-50. I think for now we commit to the extras and we just say, hey, you have to have this box checked. And in the future, maybe we can pull that back and make it more automatic. Because the user experience of needing to click that is annoying. I know that I have messed that up a bunch in the past because that option can like randomly reset for unclear reasons is what I'll say. So we'll assume extras is here. In which case we get an object that looks like this. And I think that our approach here should be to reconstruct this array separately and then reinsert it. So we could do something else too, right? So we do all this internal work here. And one of the things we could do instead is have all the work happen on like a Skeen internal property, and then just delete that whole thing and set it as a new extra when we export. That feels a little bit cleaner as well. Feels a little bit awkward to have like multiple things in the same key space. But it'll be fine. We'll do it for our test anyway. So for node in this, then not let. Python doesn't have let. I guess if Skeen in gltf2 object.extras, then object is this, but we need actually all of them. And then object is this. And then node dot type path, I think, is what we want. Not dot type path, but we need node type path in object. So I guess let's do like type path equals node type path instead. Just so that this is like not an overwhelming amount of nested stuff for people to look at. I'm kind of like, when writing this whole thing, my concern is basically that people will want new features in it. People will want it to change behavior in some ways. But there is no really good way to test any of this. The only way that I can think of is setting like full-on integration tests and whatnot. So, I don't know. Maybe we can do something with the Bevy CLI or whatnot, but this is basically like we're dynamically building UI inside of Blender so that people can insert data and then export it to a specific format. And I think we can set up an integration test for that, but it's going to be particularly annoying. So object type path equals node value, I think, is all we need to do here. And then we have this list at the end of this loop. So gltf to object dot extras scheme equals objs. So we just replace it. And that's not the variable name. So this should, I guess we should do like if our extension is enabled too. Because like theoretically you could want to turn this off. We aren't actually putting stuff in extensions. We're putting everything in extras. Maybe we should be putting stuff in extensions. I don't really have the answer for that one. I think we can just comment that out in that case. And this can go there. So if we're enabled and we have the appropriate key in those values, I guess, and it's an array and whatever, right? Like make sure this is typo, you aren't appending anything to objects. For node and object, objs, you're right. Thank you. I appreciate you. Okay. I appreciate you all. If our extension is enabled and we have this key in the extras, I think this might throw if there is no extras. So TBD. Maybe we can, I don't think we can self.report here, but maybe we can. Looking forward to using this in Bevy. So saying the problem is Blendvy might not be fair. You're not completely certain right now. You're using Avian and Tenua for the character controller. It worked flawlessly, but now the scene grew and changed. Now when the game starts, it's a gamble on whether Tenua detects the ground as something walkable, but all colliders are fine and work correctly. Interesting. Oh, is it a load speed issue? Like, is the scene not loading fast enough, but the player loading faster? Like that kind of thing? So then the player spawns in and like it's already falling through the ground before it gets a chance to collide. You added some timeouts to see if it's that, but so far did not change it. Interesting. I guess the other thing you could do, I assume you've done this, but just in case, Bevy Inspector eGUI, just to make sure that everything is all in the right places, and then just move the player back up and etc. Because you can do all that through the Bevy Inspector eGUI, like debug menu. Yeah, so if this is enabled and it's in extras, I guess I'll leave myself a to-do. Like, I would really like to report whether GLTF extras is like enabled or not, or like custom properties is enabled or not in the export, because we do need it to be. And if it's not, but you have this enabled, then you are intending to have this data, but you are not providing this data. So hopefully we can do like a self.report here at some point. I don't know. I don't know if we have access to that in the exporter. Because again, this is not, we are writing a class that works inside of somebody else's code that is an add-on for Blender. So it's not Blender code that we're writing. It is code for somebody else's extension, which means that self.report, which does work in Blender, inside of operators and stuff like that, isn't necessarily provided unless that third party like wants to provide it. Okay, so I think this will work, assuming I haven't made more typos. Chat has not said that I made more typos yet. So we're built, we throw this in, enable it, grab the information that we need. Here's player, yada yada. Here's data, export, GLTF, export. Can only concatenate string, not GLTF to export extension. Oh, dict has no attribute scheme. Okay, so we can't do dot. One of the things that I absolutely always forget is that accessing things like this, like dot syntax and array access syntax mean different things, which is really confusing to me as somebody that doesn't write Python regularly. I assume that people who write Python know that like the back of their hand, but yeah, you checked with the inspector whether any components differ between objects that are walkable and those that aren't. Could not find anything. Very weird because the character is not stuck. The spring from Tatuna just ignores it. Interesting. Yeah. The other thing is that that's also one of those complicated things where like Avian's a really complicated piece of code and Tanua is also a complicated piece of code. So like now you're debugging two complicated pieces of code that are powered by a complicated piece of code in Blenvy. Absolutely, absolutely tough. Okay, so I think we need to kick out of Blender there and restart it. Because again, remember, every time we add this plugin, it just kind of like adds to the stack of exports, which is not what we want to be doing. And we're not saving the scene. So at the current moment, I'm just reinserting all the data to start with. Let's do player, insert, Chris, 00. Cool. Export, GLTF, here. Custom properties, scheme, export. Okay, can only concatenate stir, not gltf2 export user extension to stir. So I think it's trying to give us an error. Has no attribute scheme. This is still the old code, that looks like, unless I messed something up, which is very possible. No, that's still the old code. So preferences, can I delete you somehow? Yeah, see, we have 2 type registries now. This is one of the other things that I'm going to have to do like an edge case run on. Okay, so there's the power stuff. Export. I think that we should remove this. Package this back up. Quit the application. Go back into Blender. Okay, we don't have our panel here, so it is definitely not currently installed. So we drop this in and it installs. Bevy scheme not loaded. Drop file. Not a submodule. Okay, so do we need to do this? There it is. Why does it say not loaded? Don't know why that didn't register. Definitely going to have to look into that. There's definitely a lot of like UI level edge casey stuff doing Blender UI work. Oh, what was that? That is... Oh, yeah. Okay, that's a known thing. Basically, right now I'm not inserting default data when I set up this form. So if you haven't filled out the form completely yet, you'll end up seeing a little debug message. So export GLTF, assets, custom properties, export, gather node hook, moment of truth that I exported it to a GLB and not a GLTF. Is that what happened there? Yes. Moment of truth in the sense that I messed it up. Okay, so our data is now being reformatted. That's exactly what we wanted. So now what we have is an array of a set of objects. And those objects have their type path as the key name and their values as the values. And this is really important. And this is really important because the way this works inside of Rust, which now I should probably save out a GLTF file to use as a test. What am I using currently? Event ordering is got character in it. Basically, this for all of my debug usages needs to change. So let me manually change that, I think. The thing that I don't want in the GLTFs that I commit to the repo is this like .bin here. And if you have any like cubes or anything, all the vertice information or vertex information goes into that buffer collection effectively. So really all we want is this. So we need it to look like this. I think I can make it look like this in event ordering. So then this is, instead of being that, it's this. So this is our setup for the data structure. So event ordering should crash, or I guess not necessarily crash, but it should have an issue reflecting this. So let's run that. I guess we can stop running this one. Cargo run example event ordering. And the post process has an error, which is great. The skiing GLTF extra field cannot be parsed as a Saturday JSON value object. This is the entity that we were trying to parse. Name empty, parsed as array. So I have like a bunch of logging information here. Because I feel like that's going to be a really important thing. Most people, if anybody uses this at all, the most people that use this are going to be people who do not understand how it works. And therefore, the error communication is going to be very important. Because if you don't understand how something works, you can't infer anything about a vague error. I will also describe how it works in the docs, but as we all know, people like to use things before they read the documentation. Okay, so that's all good. It doesn't work at the moment, but that's because we need to make some changes. So to be clear about what the event ordering is doing, is it's basically throwing out a bunch of logs that make it very clear which lifecycle event effectively fires at which time. This is one of the things that people always get confused about with observers, so I wanted an explicit example about that. So this is, we post-process the scene, and then there's like local and global observers for different things. So we've got scene instance ready, right? Which will fire regardless. If you don't need the scene data, if you don't need this reflected component data to do any of the work that you need to do in this scene, you can do it on scene instance ready. But if you do need any of that extra data, then what we do in the library is when we are done doing everything that we need to do, we like refire the scene instance ready with a different event type. So because we are listening to scene instance ready inside of the crate to do the work for the component reflection that we need to do, if you want to guarantee that you run after that, we just fire another observer, which is really nice because observers give us this functionality where you can say, I'm running in response to an observer event or whatever, in response to an observer, do some work, and then say, anybody that wants to do stuff right now, right after I've done my work, can do it now. Which is better than like waiting a whole frame or something like that for like an event reader or writer, or specifically positioning things like that. So the question here then And I should probably take this code out and test it as well. We do Saturday JSON from string for the extras, right? Which gives us a map of key and value. In this case, I think this changes. So we have the extras here, Saturday JSON from string. This actually will be an object still. This is all of the GLTF extras, right? This is everything. So it's all of the key value pairs, including Skeen, which is the thing that we get. So once we get this, this needs to be not a map, right? So, so we'll change this to be some value array, I think is what we'll get here. And this will be components, and we'll return that. And then we'll get rid of this. And that is just what it is. That's a reference to a value. Is there an issue with the reference? There's an issue with my ability to typo on stream. That's what the issue is. And then maybe another one. And then another issue with my ability to write text on screen. And then this, cool. So this is now an array, right? This is a vec of values. That's important because the way we've structured this data, if we iterate over Skeen, is now not key value, but just component. And I get to remove this code entirely, I believe. Because this is JSON component. So we run this. And it looks to me like everything worked. For anybody that's interested in the reflection stuff that's going on here, basically all of this code up to the top of the function, right? All of that code is for pulling the GLTF extras out as JSON. That's all it's doing. So this is then a JSON array, which is a vec for us once we've deserialized it. And this becomes that type path key with the value of the data. So when we iterate over this, we take this component, we grab the type registry for this application, we create the new deserializer, we deserialize that component using it, and then we have a component. If we've gotten this far and everything works, we have a component. And it should just be able to insert. So like the actual code to perform this gymnastics is hilariously small, which is really cool. Bevy's reflection stuff is super cool. So then debug also needs to work the same way. So currently debug just dumps out the GLTF extras. And then we're having the post-process error because our data isn't set up correctly inside of the GLTF file. So that means that this here needs to have the array wrapping around it. And now everything's good. And now we're debugging out this. In this case, it's a power level energy 10 component. But if we go look at the code, here's the debug energy 10, right? And in debug, actually, we won't have any of the code in here. But here's power level energy is a float 32, right? We don't have any code in here to handle inserting anything. That's all in the plugin. So this is just checking as an observer on that scene instance ready that we talked about earlier. It's the one that happens after we've done everything. And we're iterating over all the descendants in the scene and checking to see if they have a power level on them, which, because we define power level in the extras, which should come from Blender, then that should be there and it should log out. And in fact, it does log out. So yeah, it all works. There's a bunch of like little things that I need to fix. Like there's some rough edges. When we create the form, for example, I want to insert the default values for those forms, which we're not doing currently. Why is this not working? I have this YouTube notification bot in Discord, and it just doesn't do anything, ever. Which is like the opposite of what I need it to be doing. I'll have to find a different one. Whenever I post or go live, it's supposed to be like, hey, Chris went live or posted a video or whatever, and it just doesn't do that. And I reset it up every time, and then it doesn't do it the next time. And it's been like four videos now, 4 live streams and videos. Okay, so this now works, right? We don't have an extension, so I disabled this code. Untitled has component tests player. Component tests has all of that stuff in it, but it doesn't register anything. I guess let's try to build a small example, maybe. Do the full pipeline. I'm trying to think. I want to reduce the amount of binary blobs in the repo to 0. But if we put any geometry in the Blender scene, then you do get a bin. You get all the vertex data and stuff. So what is a good thing to do that with that won't create a binary blob? I can't think of anything. Maybe I just don't for a second. Okay, so the extension works and everything, so let's commit everything we have at least. That just thing didn't work, so we're not going to keep that. We're going to modify these 2 GLTF files, modify the Python and the Rust. Whole pipeline from Bevy to Blender to Bevy is working. Cool. And then I guess let's do a test project. Get rid of all of these files. Examples extension. I don't think I'm going to put this in examples because I don't think it needs to be one. I think I'm just going to create a project. Halo. What about a text GLTF without any textures? What is a text GLTF without any textures? Well, like the vertex data gets stored in that binary blob, right? So like if I have a cube, or am I wrong about that? Am I just like seeing something else? Right? Because like this doesn't have textures, but it still has the buffer for the vertex data. Right? Or is it something else? Right? There's 4 buffer views in here. The cube has attributes 3. It's the only thing that I can think of that has additional data. We got the whole Blender Bevy plugin working, Low. Everything's working. Yeah, you do GLB. I mean, production is GLB, right? The only reason we're doing GLTF is because it's easier for humans to read for development. And the whole thing that this crate does is write data to the GLTF or GLB or whatever. So having having people be able to look at it and go, oh, that's what it is really useful. There is a way to include buffers in the GLTF. I don't want buffers at all is the thing. Including buffers in GLTF is just this, right? So it's buffers. It's got a URI, untitled.bin in this case. And untitled.bin is right here. But untitled bin is like 840 bytes of whatever. You know? And I don't want 840 bytes of whatever. You know? I don't want to ever be in the position of somebody having made a change to a binary blob that I can't really inspect easily. Right? Somebody puts up a PR and they're like, here's my new thing. And it's like, goes from 840 to 900 bytes, but why? I'll never be able to review that. That's terrifying. Hang on. What a fucking terrifying place to find a spider. Held up over my head by a mic boom stand. If there is a buffer, even if not using meshes, just empty. Oh yeah, no, we can do it with like an empty. I am doing it with an empty actually in my other examples. Spider keeping me safe from flies. Well, I don't want spider to jump on me during stream. I am absolutely not going to be able to get that out though. There's no way. That's so wild. It like curled up into the interior of, oh, you know what? That piece actually comes off. There we go. Sorry, spider. Don't have time to save you at the moment. Yeah, it's like this little this little mic mount that I have up here, and the spider was just like, "Let me crawl into the top, into the screw, and just live there." At the end of, mind you, like a 7 foot tall boom and like a 4 foot wide, like it just like went up the whole thing. Okay, sorry. You guess it would not test the meshes, materials, components. Yeah, I don't really need it to test anything in particular, I guess. I guess I could also do like a required component on the empty. Because the empty doesn't actually come with anything on it, right? It just comes with a name. So if I do a component here that is a required component that can I set up a mesh and a material using a required component? Is that gonna be okay? I guess I new type something else, right? We wrote that exporter plugin that you were talking about, Xavier, though. Let's see. Docs.rs. Require. Okay. Is there... I don't think we can run much code when we require components. I think it has to be pretty specific, but we'll see. Yeah, default will be used to initialize the component because required components, I think the ability to do from world with required components is waiting for constructs, and constructs haven't landed yet. So it only uses the default constructor. I don't think that Mesh 3D has a default constructor because it has to take that handle. We could cheat a little bit and do like an observer on the scheme instance ready and then insert the mesh on anything that has the right component. It's a little bit of a cheat. I expect that people will use that pattern, but it's not like the primary pattern. We can do custom constructors, I think. Forget how to do that offhand. Component hooks. Right, like we can do this to set the default values. We can't do from world though, which is still what we need to do for the handles. So I don't think we can really get around this without doing something funky. And I don't really, like the intent of this example is not to be funky. So let's just do a regular like project here. Let's do cargo new, or actually let's do Bevy new. No, do I want to do Bevy new? I'll do Bevy new. Bevy new is the Bevy CLI, by the way, if nobody's seen this before. It is not, I mean, it's released, but it's not like publicly released yet, if that makes sense. Like, we're not telling people to be like, hey, go use it. It's still like 0.1, 0.2, like things are changing kind of state. So if we do Bevy new, what am I going to call this? Temp test, I guess. I don't know. And what we end up with here is a cargo project with the fast build setup. This workflows directory can go away. It doesn't have anything in it currently. Main.rs that already has Bevy set up. For us, unfortunately, it doesn't have the right version of Bevy, so we do need to change that. What are we using for this? So this has to match. I am not interested in the log levels changing. And then it's got a couple other things that are like relevant for Bevy stuff, like the optimization of packages that aren't yours, the type complexity, allow lints, and stuff like that, which are all cool. Okay, so we have a project now. The other thing that we want to do is load in and render a GLTF file with some components, right? So let's go grab whatever GLTF load code is on main. Doesn't matter, we'll just completely overwrite it. We do need an assets directory. Funny that we get the GitHub workflows directory and not the assets directory at the moment. So this is just a regular thing. The environment map light, we could go get these. I'm going to disable it for a second. And then this is going to look for flight helmet.gltf. I want it to look for untitled.gltf. I'm not being lazy, I swear. Okay, so the other thing is we need to set up the plugin. We're sitting in like a subdirectory of this, so we should just be doing a path up to the next directory up, but we do need to actually set up the plugin itself at some point. So cargo toml will be skeen, and this will be path ... I think will work. And then we do need to add this. We do want custom types in here as well. I think what we want to start out with is just running the application. I should have run the application already, actually, just in case. So let me do that while we're doing this. Yeah. This is going to be awkward because I'm working on main is basically the issue. So maybe let's not do this in a separate thing completely. Let's do this in an example for the moment. Do test project.rs, do this. We'll load untitled. Skeen plugin has to come in from the same place it comes in from everything else. I'll delete this temp test directory because we won't want it. I'm not going to do Skeen instance ready. So this should be enough. Just having the Skeen plugin and registering the Skeen plugin should be enough. So let's run the example, I guess. No, I put myself into a CD loop. Okay. Cargo run, example, what did I call it? Test project. That's how we know we're going to get rid of it later. It's got a dash in it. Okay. So, no registration found for component test player. Oh, right, because it's actually loading. So this is what happens if you have not registered a component that you're trying to reflect into Bevy. This is source lib 149. So this is in lib 149. That's this unwrap. This unwrap needs to be not an unwrap. I don't think that this should be a hard error. But it is an error, right? You had data that didn't come in. So I think from our perspective, this is an error. It could have not worked for any number of reasons. The data could be malformatted or whatever at this point, so we can't really rely on anything. What error did we actually get when that happened? No registration found for component test player. I think that we should keep the error data here. So we can't use let else because we need to keep that error. Let reflect value equals match on this. And then we have value here, which is what we want, or we have an error here. And this error, and then we're going to continue. So the type information will bail out at error, and reflect value will end up being that partial reflect value. So here, failed to, what did we fail to do? How will somebody read this? Failed to instantiate data, component data, and then we keep the error data around. Can we just, I don't think we can do this. Can we do this? Maybe we can. So if we run this, we should see an error log now instead, but the application still runs. So now we get error post-processing Skeen failed to instantiate component data from Blender, and the error is no registration found for component test player, which is accurate because what that says is that component test player exists in this GLTF file that we're loading, but we actually can't put it on the component for you because at the end of the day, what you didn't do is this register type. So if you didn't register the type, but you're trying to reflect data in, that is an error because presumably you define this data in Blender with the intent to use it, and we can't use it. So it won't crash your application because that's awkward, but it will be like, hey, this didn't work. Like hard didn't work. You will see weird behavior if you're depending on this. I feel like we should use, I don't know. I feel like we should use scenes that are applicable to the defaults instead of changing the defaults for the shadow maps and everything. Maybe that's just because I copy and paste from these so often. Okay, so test project. Currently using untitled. Untitled is not actually what we want. Test project needs a component of some kind. So let's set up what? Is there animate light direction? This is just rotating the light. Can we hitch a ride on this code? The thing actually that I probably should do is we could replicate the 3D scene behavior, which I feel like would be cool. How do I want to do that? I want to do that by setting everything up in Blender. Right, but they have an interesting component in here that will operate like this. Well, I don't think we've actually tried with rotate. We're just going to have this be rotate. It's just going to be a marker to start out with. We can always modify it in the future. And then rotate is going to be inside of update, I believe. Unless they did something funny with fixed update, which is possible. Update, rotate, perfect. So the thing that it doesn't exist yet is this rotate component. This rotate component is going to be a marker component to start out with. We do need to reflect the component data. I'll also introduce debug here. I think we need more here, but I can't remember offhand what. Oh, I didn't reflect here. That's what. And I don't need this. So we've got component, debug, reflect. We reflect the component data. I think this is enough offhand. So we run this project. Well, let's start with getting rid of Blender and reopening it. So we've got this scene now. We don't have a running application, so we do need a running application at the moment. I am thinking about doing things that would not require you to have a running application. But it's kind of not important until it ships to other people. You reduce the number of objects in your scene and now your problem is gone. That's the collision problem. Good stream to have in the background while debugging. Nice. Glad you're enjoying it. I'm glad you fixed your error too, or not fixed it, but at least like debugged what was happening. The number of objects in the scene. Interesting. How many objects do you have in your scene? Like, is it a massive, massive amount, or is it... Okay, if we run test project, this should run. There's an error, path not found. Yes, path not found because that GLTF file doesn't exist. That's fine. So we should be able to, in Blender, fetch Bevy type registry. Looks like it worked. And we did rotate here, which doesn't look... Oh, you know what? I didn't register it. If you don't register it, it doesn't show up. That's what we talked about earlier. Register type, rotate, right? So now we'll restart this again. That is one of the awkward things about this workflow, is that your components are now an API. And thus they behave like an API would in terms of how you evolve the schema over time. So like we've got rotate here, right? And this doesn't have a form to do. So it might not actually work because I didn't test this. But let's see. Good time to test it. Let's go into assets for Skeen. This is untitled. We're going to do... Did I say we're doing GLTF? I said we're doing GLTF. So marker currently doesn't handle... or the add-on doesn't handle marker components. So marker components are components that effectively don't have any data. This would, in general, not be an issue if we were setting default values, because I think the default value for the marker component would be an empty object. That's what Bevy expects. So I think that I'm going to not do that fix right now, and I'm going to change the component. So this component can have like speed, which is an F32. Because we know that works. That's one of the things that I do need to do kind of after stream before I tell anybody about what this is. Not that I'm not telling people right now, but there's a bunch of smaller workflow things that I need to do. Like, how do you remove a component from this list, for example? So if we do rotate here, this should go in. No property group for rotate. Okay, what are we looking at here? On select new component, additional properties. This is a struct with a speed that's an F32 that reflects component. And the error is that it didn't exist in the Skeen property groups. Line 165 in update component form. So let me check that. So this is a log that looks for the type path in the property groups. Oh, you know what? I am silly. You know what I did? I hard-coded the key names that I was working with because I knew that I wanted to work on them incrementally. So unfortunately, I did hard code like only component test player and only task priority to get registered because I didn't want like so when you do the registry information fetch, there are like 350 types by default, and I didn't want to have 348 errors while I was building out one. So unfortunately, I hard coded that. That's on me. So let's get a reinstall here because oh, I didn't set it up correctly either. Test project rotate is the issue. Looks fine. Edit preferences, drag this in. Because we're installing, I will start Blender from scratch. We will fetch the type registry data after we reboot the game. Okay, registry data fetched. Rotate. Oh, it automatically underscored it. This is going to fail again. Welp. That's how it goes. This won't always be hard coded, so open Blender again. Make sure that this gets in as a add-on. Quit so that we only have one instance running. Reboot Blender. Fetch the data successfully. Find the rotate component, click it, insert, have the form, adjust the speed, grab this, move it, maybe don't move it. Let's do another mesh. Let's do something that can turn, like a cylinder. Let's move it on the y-axis by a bit. Let's insert the component again and do like something maybe slower. Let's do a mesh that is a torus. Let's move that the other direction. Let's insert this on that, and let's yet another. Let's export this into the assets directory. Make sure we have GLTF on. Make sure we have custom properties on. Export this. Everything successfully exported. So theoretically, we're not using those speeds, actually, now that I remember. We also need to move the camera. But they are rotating, if you saw that. Whereas camera needs to be way further away. Let's just make these, I don't know, 10 instead of 0.7. Maybe not that high on the y-axis. Maybe exactly even them with them on the y-axis. Maybe I forget which way we're going here. X, Y, Z. I think they're spread out along the Z, so we want to be on the X. Cool. They are rotating very clearly. So that is a successful, like, instantiate a component inside of Bevy, run the Bevy app, fetch the registry data from that Bevy app, build the UI in Blender, insert different UI in Blender, or insert different values, get those values exported into the GLTF via the export extension, get them into Bevy. Bevy handles inserting those components. That was the entire flow. It was there are speed bumps, obviously. This is still like the development copy of it. I'm hard coding some things and whatnot, but that is actually the entire pipeline working. The other thing that I would want to do here is not with rotate, but just rotate. And this is what? Delta seconds. That means higher speed results in slower movement, right? So let me multiply there. It is absolutely hard to tell that they're moving in different speeds. So let's do rotate X. So yeah, here's the rotation. Is the light rotating too? Yes. The light is rotating too. The light rotating was this. The light direction animates because that is just in the example that I chose to copy. But because we're doing rotation, let's not do the light rotation. Okay, so this is then the whole process. This is it. The data from Blender is being pulled into Bevy. The reflection works both ways. The UI builds, you can modify things. You can fetch the type registry. There's a lot of little things to clean up. When you insert a component, we don't currently insert default values. So you do actually have to set all the values yourself. That's a fixable thing. You can't remove a component right now. That's a fixable thing. What else? It's Bevy 0.16, so it's based on the main branch. That's a fixable thing. The components that we process, we need to process more types of components. Currently, we do, I think we do markers and structs and simple enums. But the marker support needs a bug fix, and then rich tuples need to be done. What else? Yeah, I think rich tuples are the main thing. Or I guess enums, sorry, rich enums. I don't know that we're going to do tuples. Tuples don't really make sense. I guess the only time tuples would make sense is if you have too many components defined in Blender. So we'll need some kind of potential solution for that at some point, but people need to use it before that's an issue. So we'll deal with scaling issues later in the sense that, like, if you insert, what was it, like 16 components and you try to insert a 17th, then Bevy will be like, I don't like that because of the tuple stuff. So theoretically, we could detect if there were that many. No, actually, we're doing individual insertions. That will never matter. But yeah. So that's all the stuff. What's next is the question in chat right now. What's next is to basically fix out all of those things. Like, just go through, do an exhaustive kind of implementation of the components. So where is that demo? I have component tests here. Component tests has 3, 4, 5, 6 different types of components. The ones that are currently working inside of the UI are player and task priority. Those are the ones that I had hard-coded. So player is just a regular struct with some fields and values. The primitive values all work. And if you do like a U32 or something, it should lower bound at 0. Things like that work. This is a component in the same vein, but it has a struct as a sub property. So I need to make sure that this recursion actually pans out correctly. The hard coding of component names does also need fixing, in your opinion. What do you mean by that? I mean, the hard coding is going to go away, is the intention. But what do you mean by the hard coding of component names? Like the hard coding here, this if is just going to get removed. This is literally just so that the errors that I see are localized to the component that I'm working on. It's a development tool. It's not a thing that's going to ship, so to speak. And then documentation. This is 800 lines of Python, which, while being fairly small in terms of like total line count, a lot of this does need to be pretty documented. Yeah, if that's the one you're talking about, the intention is to remove that completely. That's not going to be there. It being hard coded is just so that so actually, let me explain what this code is doing. This code is doing, with the BRP response, so the Bevy remote protocol is giving us the registry information. So this is all of the registry information for all of the types, right? That's what we get here when we do this key and value. The key is every type in the Bevy app completely, and the value is all of the type information that we can use. We take that type information and we call this recursive function to build out a property group. Or if it's not a property group, it also works for like regular floats and stuff. If we build a property group, it registers that class. So then we have effectively reflection information via the property group annotations field inside of the Blender add-on for any of the types that are components inside Blender. And then if they are components, if we have reflected component data, then we add those to the component list as first class things that you can select in that drop down menu. But the property group here all of that stuff gets registered at the moment.
So this will effectively be unrestricted at some point, right? Currently, we're only filling the, how do I say this? We've got basically a list of all of the custom property group types. Make property. I think we've covered this in another stream, but make property, if you go into the struct handling, and you can see that like we aren't handling tuple structs or tuples right now. But if you look at the structs, which is one of the things that we were looking at, like component type player or whatever, we go through all the properties in the reflection information. We build up the annotations key recursively with the next type, and that is set into this annotations and stuff. And we build up a custom like Python type class. I don't know what to call this exactly. Using the capitalization of that component full module path. So this actually ends up being a Blender property group with all the fields we need on it defined, which is what we use to build out the forms. Yeah, so everything will go into this. Everything will get a form entry, effectively. There will be no if statement blocking it. Yeah, but you can see like we aren't handling arrays. Currently, we're only handling like string, like simple enums. So this function basically needs to get built out for the other component types. That's what needs to happen next, really. You can see that I'm handling all of the primitives. So if you do like a U8, U16, etc., it sets the min and max on the int property. F32 or ints actually also get their min and max set. One thing that's interesting that I don't know the answer to is that Blender sets these defaults to I think the i32 version, even if you have like a U size. So if you try to use a U size, I don't think you can actually set the top end of values inside of Blender, because this uses an int property and there is no, as far as I can tell, uint property. So we've got int property here, but I don't think there's a uint property. So if you actually intend to use like from 2 to the 31st to 2 to the 32nd values in a U size or a U64 or whatever, I don't think you can actually set those values in Blender. I don't know if anybody has a use case for that kind of thing. I'm moving forward with basically the idea like if nobody asks for it, then we don't need to deal with it. Because setting a value to like U64 max feels really weird. I don't know why you would do that. And human written values tend to be somewhat different, but I don't know. Maybe somebody has a use case, and then we'll have to figure it out. What are one of the other things? Subtypes. Subtypes are interesting. Is there going to be a docs page that I can find easily for subtypes? Property subtype string items. That is what I'm talking about, but it doesn't explain anything. Subtype. Okay, so property subtype items. This is really interesting as well, because Blender has a number of editors, right? If you have like Glams, Vec 4, Vec 3, something like that. Hey, Hot Opus. If you have a vec4, vec3, whatever, that could be a color, right? Or it could be some other kind of data. So there is a way inside of Blender to define what kind of editor it should use. And I think something that could be very interesting is if we can stuff this information into the reflection data using like an additional macro or something, then we could have this be set for anything that you own. The only downside is setting it for third-party crates is really weird. Because how would you put a macro on, say, the cuboid from Avian, like the cuboid collider or something, right? The collider constructor. But I think having it for userland code would be interesting. So, what is it? Like, linear color is an obvious one, right? If you have a value that's linear as RGBA, then we can tell it that, hey, this should be a linear color picker, like that kind of thing. So that's something that I'm thinking about for future work. But yeah, that's all the like, that's everything that's new. We've basically accomplished all of the hard problems. Everything from here on out is just filling out the functionality and doing error handling correctly, which is sweet. This is not the best example, but these rotate components did come from Blender and are being instantiated in Bevy, which is really cool. Yeah, the other thing is that it's 0.16 only at the moment. And thinking about workflow wise, switching Bevy versions could be an issue, right? If you have a number of crates and you've put that component data into your objects and stuff like that, how do you rewrite, like, I don't know, let's say Avian had like Avian cuboid collider and Avian 2D cuboid collider or whatever. That doesn't make any sense. But like, let's say it changed paths from like the prelude to, I don't know, somewhere else. Then that breaks the reflection, as far as I understand it. So you would have to go in and change all of them. But yeah, I think that I'm pretty happy with this in general. One thing that would be interesting, we are currently like letting you set whatever you want here. This is on the Taurus. This should just work, but I'm just going to test it. We're letting you do like this kind of thing where you set multiple components on the same object. And I think currently we use the last one in the list. Right, so that's -4. It's spinning the opposite direction of everything else. So theoretically, if you had like complicated configurations for different components, we could allow you to drag and reorder these. And through doing that, you could set up like 2 complicated debugging setups and then choose which one you actually wanted. That's one of the reasons that we decided to do a list here or not. You think you missed a bit of the U64 max thing you just said, but you notice Blendview does not allow me to assign to the collision layer all because the field won't accept. What is that? U64 max? I don't know that value offhand. I think that's U64 max, right? U32 max, maybe? Yeah, U32 max. Yeah, collision layer. If I remember correctly, collision layer is also a bit field, right? Yeah, it's a layer mask. So this is also a thing that is interesting. There are different kinds of values that use data types like U32, but are actually bit masks. And currently, no matter what, setting a bit mask as a U32 is a terrible experience. Like, it just is. I've done this inside of Blenvy. Like, it would be the same thing for this project right now. Setting bit masks like this is terrible. Now, what you can do is this kind of thing, where there's a really useful pattern in Blenvy, which I think will also apply to this project, where you can basically create a marker component that is that has required components or whatever, or default values, etc. You use that marker component inside of Blender as the UI component to be like, if this is an enemy and enemies are on layers 2, 1, and 5, then your game can know they're on 2, 1, and 5 when it instantiates that value, right? But Blender doesn't need to know that, right? So instead of having the bit field, you can go look for the enemy layer component that you made, or you can make that an enum or whatever, right? And you can set those values using required components or observers and hooks or whatever. Now, that's not to say like it wouldn't be cool to have a bit field editor and to be able to modify that in game or in Blender and whatnot. But it does seem like if you're doing that a lot, you should be doing something a little bit more configurable in that sense. Like you had almost 1,000, or somebody had almost 1,000 objects, right? In their Blender scene with Blenvy. Are you gonna set the physics layer for 1,000 objects? I don't think so, right? I think at that point you have to do this other approach where you have like a marker component and then use like a component hook to replace that with the actual layers inside of your game logic. And then in Blender, it's really simple because these 500 things are enemies. Those 300 things are, colliders, whatever. But you don't get yourself into the trap of like, okay, this bit field has 0, 2, and 5 selected. What does that actually mean? Which ones do I actually need to select? Did I forget to select one when I, did a refactor and changed which layers need to be active? So yeah, I don't know. I go back and forth on it. It would be nice to have the bit field like as an editor inside of Blender. It also strikes me as the kind of thing that's like, you should have a different way of doing that anyway, right? Right, like even if your component is just a vec of these layer masks, like if it's a vec of game layers, and that's the component, and then the component hook for that just takes the game layers, ORs them together or whatever, and inserts the collision layer, that seems better to me than doing like direct bit access. Because I don't know who's going to remember what layer 2 is. You know? I'm never going to come back to a project and remember what layer 2 is. But yeah, we could do there is some like ability to customize some of this stuff. I don't know. It would be cool to have like user extendability. You would say a bitmask editor is the thing that's really nice to have if you want to do things dirty for testing, but the other way is better. Yeah. Yeah, I see people use the bitmask editor in Godot all the time for like their collision layers and stuff. So I don't think that's an unreasonable like thing to want. Maybe it's not Godot. Maybe it's something else. No, I think it is Godot. Maybe it's both. But yeah, like you end up with this GUI where you just like do checkboxes and stuff. But yeah, I think the vast majority of people, the vast majority of programmers don't really understand bitmasks. And you kind of just need a better UI for it. So it is kind of annoying to have to manually do that, but I don't know. That goes back to the other thing too, right? As like a design problem, if you have Avian, right? Avian has, let's see, docs.rs, Avian has like collider constructor, right? And collider constructor is an enum with a whole ton of variants. And these are like scalars, like S scalars. So like, does this come up as scalar or not? The other thing is like X length, Y length, Z length. When you get to this enum, it's not going to show as like a vec3. You know, it's going to have 3 separate X, Y, and Z fields. Unless you custom code something to be like this X length pattern of 3 scalars is always a vec3, you know? But then like you get to this and it's like, is that the same? Is X length, Y length, Z length, and border radius a vec4? You don't really know unless you're told, right? Like, could you represent this as a vec4? Clearly, because it's an F32 for the border radius. But like, you probably want to see border radius in the UI. You probably don't want to see W, you know? The other thing that's interesting is like, we probably want to be able to link some of these properties. So I think that we can do that with custom properties on the way that we're doing things. But I haven't looked into it at all yet. So for example, if you have a cuboid that has an X, Y, and a Z length, right? And you're in Blender doing your thing, right? And you're like, this cuboid. And you're like, okay, the values for this need to be linked to like the item's dimensions, right? That's really useful because then you can have a collider constructor for the cuboid and you can do things like jump in here, scale it to 10 or whatever, right? And then come back out and you look at the data and it's 2220. And you don't really want to have to come back in here and modify these. You think you can do that out of the box using Blender driver? Yeah, I haven't looked into it too deeply. My understanding is that custom properties can be, I guess, driven is the right thing. But no code needed. You think it'll just work? The other thing that's an issue that I think is less of an issue now, actually. But the other thing that's an issue is because of the way that I got to some of this functionality, we're currently doing these forms. This custom property form, the property group is stored on the window manager at the moment. And I don't love that. But it was the easiest way to get it all working. So we could instead set these list objects potentially. No, we can't, I don't think. Yeah, anyway, the really awkward thing about this is, like, once you start setting properties, Python will, or Blender will kind of complain if you set them in the wrong way. So it's unclear to me whether we can set property groups in this list or not. Right now, this list is a list of component data. Where's component data? There's component data. So it's a list of component data. So if you remember from earlier in the stream, anybody who's still around, we had type, path, value, and name. Value currently is getting set as like a custom property, I guess, and type, path, and name are getting set as this property group. This is one of the, well, that was weird. This is one of the things that was, I discovered how to do on the plane correctly. Where is this? Here it is. Oh, that's not it. Here it is. So this is the update component data function. So this runs, if I remember correctly, anytime you update one of the fields. So if we've got that scheme on the object, we go to the active component index. If the type path is in the property group, we do some stuff. And for key in component fields, we get the data from the property group. We stick it all into this new data. And then we set the active component's value to new data. And then, yeah, anyway. I think you just right click on the speed widget and select insert driver. But yes, the workaround for generic types, setting the properties to the window will probably mess things up. Yeah. So you're saying, they'll let me copy the data path. I don't know what the data path is. Active editor.speed. Yeah, so active editor here is a window manager. So you're saying that if I do something like this, I can't click on this. Maybe up here. Maybe copy as new driver. No, let's do not location. Where do I get dimensions from in here? Add driver is not present in the right click menu. Yeah. I can't click on dimensions. I can do it for scale. Right? So scale X can be a new driver. on, I guess it can't be a new driver for this value. Is it not an F32? It is an F32. So yeah, I don't know. I need to look into the drivers and whatnot. It would be very cool to enable that to work. I think that the way that I have it coded right now means that it won't work. Because we basically have the custom property, pointer property on the window for the active form, which allows us to build out the UI by doing the property assignment to each of these fields. And then when you change that data, we grab all of that as a dict and insert it into the value for the component in this list. So when you click on something in this list, we are setting the active editor on the window to that property group via pointer property. Whenever you change any of those values, we're serializing them into the actual value. I guess it's possible that we could set the form in the same place, especially now that we have the export extension, we could just drop that data. That was definitely one of my concerns with putting it on the object, is that if you put it on the object, then it shows up in the custom properties and the export. But with our custom export extension, we can filter that out. So I'm less concerned about that now. So maybe I'll do that. But yeah, I think that's it for the stream today. Fairly light stream. I knew I could get this all working, so I wanted to get it working, show it on stream and whatnot. I am going to now go chase down a bunch of edge cases and fill out the rest of the functionality and like investigate drivers and stuff. So thanks for hanging out, everyone. I'm going to go get some food because I didn't eat this morning. And I'll see you all Saturday for the next stream. And if my bot is working, then there's the Discord link. If not, then, well, that's on me. Oh, that's hidden use copy button. Great. That worked really well. Discord, thank you. Here you go. If anybody wants to be in the Discord, ask questions about what we did today and whatnot, there it is. But otherwise, I'll see you on the weekend. There you go.